Hello guys and welcome. I hope that you're having a great day or a good morning or a good evening. This is iPlay4K, aka iPlay8K, aka iPlay16K, one of the first YouTubers that showed you 4K resolution gameplays back in 2013 on my 4 Radeon R9 290s in quad crossfire. One of the first YouTubers that showed you 8K resolution back in 2015 on my Ford Titan X Maxwell GPU architecture in 4-way SLI. And the first YouTuber that showed you first 16K resolution gameplays in PC gaming back in 2016, April and May of 2016. And today I would like to share a serious prediction with you in PC gaming industry in 2020, and I would like to predict the best gaming CPU in 2020. By the wallpaper of my 16K resolution, guys, this is the 16K resolution desktop, but I'm not only running the desktop at 16K resolution, I'm always running 90% of the PC games at 16K resolution, at least just binge them. 99% on my 2 Titan RTX and SLI. So guys, why I think that Core i5 10th generation Intel CPU, which is the 10600K, will be the best gaming CPU in 2020. Pretty simple. This CPU will feature 6 physical cores, and it will feature 12 logical cores, which is 12 threads. So 6 cores or 12 threads. And in Windows, when hyper-threading technology is enabled, you can use 12 virtual cores. Okay. It's going to be boost up to 4.9 gigahertz on Turbo Boost, which is 200 megahertz faster than predecessor of Core i5, which is Core i5 9600K, which by the way is still till today date, which is January 2020, is the best gaming CPU. That's why I'm running my Core i9 9900K. Let me real quick go ahead and show it to you. That's why I'm running my Core i9 9900K with only 6 core and 6 threads. When 2 cores disabled, 2 physical cores disabled, and hyper-threading technology is disabled, so only 6 core, 6 threads when I'm playing PC games. Why? Because I'm receiving additionally an extra 1 FPS. 1-2 FPS when comparing, it depends what kind of FPS average. If FPS is above 60, I'm receiving about 2 FPS average with this overclock. In resolution 4K and above with 5.3 gigahertz, 6 cores, 6 threads versus just 5 gigahertz, 8 cores, 16 threads. Threads, guys, pretty much is about 1.5 times slower than physical cores, okay, because they're creating a lot of latency. And Intel CPUs with extremely high frequencies, guys, it is outperforming physical cores of any AMD physical cores, okay, because even the Core i5 9600K can be stable at 5300 megahertz per core. This type of performance is unmatched for any AMD Ryzen 3000 series in PC gaming. It's just simply unmatched. And I'm not talking about 1080p, 1440p. You can also go ahead and do the test 720p and stuff like that. Guys, 1080p is the garbage, just like AMD garbage CPUs. And I know the companies is recycling their 1080p display screens, and they're doing for you 240 Hz and even 300 Hz, but it's all recycling. So they still can gain some profit before everyone will switch in the end of 2020, in the beginning of 2021, in 4K resolution. Because 4K resolution displays will be so cheap, they're going to run $300, $400 for even 60-inch at 60 hertz, and 120 hertz 4K resolution screens will be around $600. Nobody will be playing on 1080p screens that retailing $650. No matter what will be the hertz, when we will receive at $600, $500 4K resolution 120 hertz. Trust me, when they will see the pixel density and 120 hertz, even the highest hertz horse will just jump on that. Okay, and it's going to be a switch, and when they're going to jump on that, they will realize that they were buying garbage CPUs by AMD, and those CPUs is Ryzen 3000, 2000, and 1000 series, because they're pretty weak, and all what AMD can do, they can confuse you with the cores like they usually did back since with the FX relaunch series 8-core CPUs, because they cannot show you a real life performance without confusing you with the cores. That's why their main marketing idea, to confuse you with the cores and to show you the benchmark, gaming benchmark in 1080p and maximum 1440p. They're not showing 4K resolution. The reason for it, why? Because there's a clear winner there. Core i5 9600K will dominate any AMD CPU by at least 10% in terms of the FPS at 4K resolution in 99.9% of the games. This is the reality. And when you're going to go above 4K resolution, and I can go with Core i5 9600K all the way to 16K resolution, and there is no other CPU can get close to my performance in terms of my CPU performance during that resolutions, because above 4K resolution you don't need more than 6 core 6 threads, guys, and above 4K resolution 6 core 6 threads, you're not even going to utilize 50%, not even going to utilize 50% of the 6 core 6 thread CPU. It's above 4K resolution. At 4K resolution maximum, you will utilize 80%, 85% that I saw. This is the maximum of the 6 core 6 threads. But if you're going to have, let's say, 16 threads and 8 core CPU in 4K resolution, you cannot run that high frequencies, and the frequencies is the key, because at 4K resolution and above, we're utilizing less of our CPU, and the key will be here is the frequency. So we can execute this type of instructions, CPU instructions, in our PC games as fast as possible. We don't need to execute them kind of during the slow process, but fast. So what multi-cores means on CPU, guys? It means that you're loading this data for a long period of time, and during that long term you're winning because you're having a lot of cores. Even with the latency delay that is splitting, you're still going to win because you got to load a lot of data for a long period of time. Because you're loading a lot of data, you need to utilize a lot of cores, and 6 cores, 6 threads is not enough, and during this time you're going to win. Let's say with 8 cores 16 threads, or with the 16 cores 32 threads. Okay, but in PC gaming, you're not utilizing for a long period of time your CPU. You're just utilizing quickly, half of the second, immediately this is going on. This is the communication between the GPU and CPU, and this communication needs to happen very quickly because the GPU is way faster than CPU. Okay, that's why there is no long-term processing instruction on a CPU. It's very quick, and the faster CPU frequency, the better it is. And as I tested, guys, 99.9% 4K resolution games, I only utilize 85%. And name the game that will bring my CPU above 90% utilization and the CPU, which is i9-9900K, 8-core, 16 threads, emulated, acting as i5-9600K with only 6 cores and 6 threads. Name the game that will utilize that emulation of i5-9600K at above 92%. And pretty much you need to add additionally 2 more cores at least when utilization in a PC games, when your utilization in PC games is above 92%. That is a clear sign that you need to add at least 2 more cores or 2 more threads, doesn't matter, because the threads will be acting the same. They will just generate you a little bit more of the latency delay, but still it will give you that performance. But the physical cores will give you as fast as possible. That's why I shut down the hyper-threading technology on my i9-9900K when I'm running the games, to terminate all the latency delay, unnecessary latency delay, and receive as fast as possible the lowest latency delay communication between the GPU and CPU. Hopefully this makes sense. So this Core i5 will finally feature 12 threads just for the scenarios when you will utilize above 92% of your 6-core 6 threads, which I don't know the game actually that does it in PC gaming. Or it will give you as a backup option for your workstation needs when you're not playing PC games. And trust me, if you're processing one video at a time and playing games, 6-core 12 threads will be more than enough, because I just recorded over the iPlay4K.com YouTube channel when I was encoding 2 8K resolution videos to a lower bitrate of 8K resolution videos. At the same time, I was playing great game and was receiving more FPS on my Core i9-9900K emulated as Core i5-9600K with only 6 cores, 6 threads, and without utilizing 92% of my CPU usage. With 6 cores, 6 threads, 2 8K streams encoded to 2 8K streams while playing great game that was released in 2018, still receiving the higher FPS that AMD 3000 series processors can deliver without encoding any videos, just playing simple great 2018 game with the same Titan RTX. So guys, this kind of make you think a little bit. And the answer is higher frequency. The answer is each Intel cores are much faster than AMD cores. Okay? And just because that frequency, and AMD can do nothing about it. AMD in 2019, those marketers, naysayers, and AMD fans were screaming, come on, it's just killing the Intel. No, nothing is killing the Intel. Nothing is outperforming the Intel in PC games. Okay, and AMD cannot even outperform Core i5 9600K overclock at 5.3 gigahertz, which is pretty much easy overclock for any Core i5 9600K out of the box. All what you gotta get, just get yourself all-in-one water cooling system by Corsair H150i Pro, and get yourself the liquid metal thermal compound paste. You set to go. AMD cannot touch even the raw stock frequencies of Core i5 9600K. When it's overclocked to 5.3 GHz, it's receiving at least 10% higher FPS in any games, 99.9% that I tested. And naysayers and marketers showing you only 1080p and 1440p, and you know why? Because there is a reason for it. If they're going to show you 4K resolution gameplay, and 4K resolution gameplay is the future, you will realize that Core i5 9600K is the best value as gaming PC in 2018. And the new king in town is coming. Much faster, much better Core i5 10th generation, which is Core i5 10600K, that in my prediction will be at least overclockable to 5.3 gigahertz with the 6 core, 6 threads. And there is a possibility, if you're going to disable the hyper threading technology, just to use the 6 core, 6 threads as a lot of physical cores without any logical cores, you will achieve 5.5 gigahertz. And this 5.5 gigahertz, based on Intel formula, the way of the performance cores, performance to the next generation of the cores, Intel cores, I would say to match Core i5 6 core 6 threads 10600K, you will need 9 gen 9600K clock at 5.7 gigahertz at least, 6 core 6 threads, just to match it. Okay, so you can see the depth. You're receiving additional 500 megahertz, 200 megahertz at least as minimum, just because we're running the next optimized revised cores, the next gen, 200 megahertz, and then additional 300 megahertz stable overclock on top of it, 500 megahertz additional boost. And already 9 gen was overperforming the fastest AMD CPUs by 10%. The Core i5 9 gen was outperforming by 10% the fastest AMD CPUs. That means that we're going to be outperforming the Ryzen 3000 and about 3000 series and about the fastest Ryzen 3000 series CPU in about 15, at least 15%. Imagine scenario. Core i9 9900K emulated to 9600K, showing the fastest FPS for that type of CPU. Let's say 8K resolution, 2 Titan RTXs. It's showing 60 FPS in Battlefield 3, 65 FPS average, 65, 70 FPS average, and let's say 60 FPS. It's showing 70, 65-70 FPS, while with shadow play recording, without shadow play recording, it's average 70 FPS in Battlefield 3 running 8K resolution. But let's go ahead and assume that it's 60 FPS, right? And let's go ahead and assume it's 8K resolution, okay? It's a i9 9900K emulated as i5 9600K, because this type of scenarios for i9 9900K showing the best performance in games when it's emulated to i5 9600K, because the less cores, the less latency. Even the more physical cores, guys, creating you the more latency, because there is a controller that controls, okay, this core is busy, it's not, okay, if it's not, then I'm going to go ahead and load it. If it's busy, then I'm going to go ahead and load to another one. So this time takes a nanoseconds to decide by the controller to check and decide if the core is busy. It creates the nanosecond latency delay. And the more cores you have, the more it will check on each core and make sure which core is loaded last. It's going to load this type of CPU instruction. It's creating latency delay. And when you have 32 cores, physical cores, it's going to create some higher latency delay versus 6 cores. Okay, hopefully this makes sense when it's loading the instructions on the CPU to compute. So here's the idea: 60 FPS, Core i9 9900K over emulated to 9600K at 5.3 gigahertz. Okay, AMD at this scenario will show 54 FPS, which is 10% slower. So it's losing 10% slower at least in any games that I tested, 99.9%. And I tested the AMD CPU at my friend's computer, and I decided not to get it. So it's losing 6 FPS, right? It's 54 FPS versus the 9600K 5.3 GHz 60 FPS in any games in 4K resolution and above. I'm not talking 1080p, guys. I'm not talking the 800 by 600. I'm not talking about this, resolution for the people that already can achieve this resolution on the iPads with the similar visions. With the similar visuals, not visions, with the similar visuals on the iPads already. With the Apple A13 or A12, the iPads only right now in 2020, January 2020, only the iPad A12. You can still achieve, even without the Pro extension, the same visuals on the 1080p on the iPads already with the A12 Bionic chip. Okay, so why do you need the heavy big bulk PCs playing that when you can connect your iPad using the HDMI bundle cable to a 80-inch TV 4K resolution that you just purchased for $600? Get yourself a wireless controller for $29 on Amazon and enjoy a lot of titles, PUBG and Fortnite and stuff like that without any problems, 1080p with the kind of almost similar visuals. We're talking here 4K resolution. We're talking here the future or a present for a lot of people with a brain, with a lot of people that didn't make a bad choices in the past, that was playing already for at least 2 or 3 years so far in 4K resolution. I jumped on this 4K resolution course back in 2013, but a lot of people probably jump it in 2018, 2017 with the two GTX 1080 Ti's, with the two RTX 2080 Ti's, okay, or two Titan XPs and SLI. So here we go, 4K resolution. So that means that we're losing 6 FPS, 54 FPS on the AMD, the fastest Ryzen 3000 series CPU, versus the emulated i9-9900K to i5-9600K at 5.3 GHz, 60 FPS, versus Core i5 10th generation 10600K at, are you ready for it, guys? 70 FPS or 69 FPS. The boost in performance, 69 for i5 10th gen 10600K versus 60 FPS 9600K 5.3 GHz versus the fastest Ryzen 3000 series 54 FPS. 54 versus 69. Which CPU would you choose for gaming? And I'm talking when we're going to, of course, overclock the 10600K at least 5.3 gigahertz. But I believe it's going to go to 5.5, and for sure we'll receive 70 FPS at these scenarios. Will be if 60 FPS will be shown on the 9600K. I'm pretty sure we're going to show at 5.5 gigahertz with 6 cores, 6 threads, Core i5 10600K. We will show 70 FPS. And on Ryzen we'll be showing 54. Which will you go, guys? Which gaming CPU? 54 FPS or 70 FPS? I'm just curious. Okay, of course you will go 70 FPS because that means that even with the cheaper video card, you can receive the similar performance that you will receive on the AMD with more expensive video card. And this is the reason why AMD never showed you 4K resolution test, guys. All what they need to do is just show us at least 5 games, 10 4K resolution test, and you will realize it. Or even that, let's see 8K resolution test when the CPU utilization is below 40%. Okay, at 99.9% of the games that I tested, below 40% of CPU utilization for 6 cores, 6 threads at 8K resolution. Okay, 16K resolution below 30% on a 6 core 6 threads utilization, below 30%. Okay, and we're talking the future, so you can see the future predictions right here. So CPU will be outdated as the component for the PC gaming, and all the way till 2025. And when in 2025 we will see the 16K resolution first display that PC enthusiasts will have. PC gaming will be dead, and we will switch to iOS devices, to let's say A18 Bionic chips that will be featuring 16 cores on CPU, 24 to 32 Naven cores for the AI, and around 32 to 64 GPU cores. And it will be for CPU gaming, for the PC gaming, for the console gaming. And in 2023, the greedy console companies like Microsoft and Sony will realize, oh my god, we are using very cheap parts by AMD, video cards and the CPUs. We need to go ahead and switch our idea to a faster components by Intel and by Nvidia to save our business. And this is exactly what they're going to do. They're going to reintroduce PS6 and Xbox Z, or whatever they will call it, okay, with the Nvidia video card on that, latest Nvidia video card, just to be safe for another, from 2022-23, for another 2 years in 2025. And then it will be game over for console gaming, game over for PC gaming. AMD will go bankruptcy. Intel will compete on enterprise level in data centers, as they do right now. They pretty much dominate in data centers since 2013, even when AMD already had 64-core CPUs, server CPUs. Some of you guys even didn't know that Ryzen is revised version of that, couple of revisions, and those CPUs was completely garbage. And this is what will happen with Ryzen. It will similar affects fate for the Ryzen 3000 series, and similar server 64-core CPUs by AMD fate as well to the Ryzen 3000 series. So AMD will be bankruptcy, okay, because in 2021, guys, everybody will realize when Intel will release their newer non-attack processors, they will realize that AMD is over, okay, and AMD will still be getting some money, some profit from the consoles till 2023, 2 more years. But then they will around bankruptcy level, and 2025 there is no more AMD, just like Cyrex that AMD purchased, just like the Savage video cards and stuff like that. And just technology is not fast enough to compete on the market. And what will happen with the Intel will switch us again to enterprise data centers, fighting Nvidia in data centers, because it will be no more Nvidia in PC gaming as well in 2025. The last Nvidia GPU architecture will be just right after the Ampere. Ampere will be the last descent that will be known throughout the all PC gamers, when PC gaming will be like a great industry, still great industry. Ampere will be the last GPU in architecture by Nvidia. The next GPU architecture by Nvidia will be great. Okay, we'll introduce a solid 60 FPS and 16K resolution. The last GPU architecture after the Ampere. The next GPU architecture after the Ampere GPU architecture by Nvidia will show a 16 FPS at 60 FPS at 16K resolution, but it's already will be only used throughout the PC enthusiasts, because most of the gamers will be switching to iOS devices, because iOS devices will be capable to run 4K resolution like no problem. Okay, and as again idea connected to through the HDMI cable bundle to a TV, get yourself wireless gamepad, and putting out of your pocket if it's not convenient for you to play on a small screen, and play on a big screen like a console, that iOS devices. Okay, and yeah, and Nvidia will also be dominant, try to compete with the Tesla company for the automation cars, because they will produce a lot of automation hardware, and probably Nvidia will produce their own automation car, just like Toyota or Honda, and Nvidia will get to that market. Nvidia will also compete on enterprise level, and there is no more gaming for the Nvidia. Nvidia will be lost at that point. And competing with Intel in the data centers, and competing with Tesla on the automation market for the cars, AMD will be bankrupt, and that's it. This is game over, and people will be playing iOS devices, and it's not going to be a streaming services. Streaming services will be dead as well. Streaming services will survive, will be pretty much shining from 2021 till 2025. 4 years. I'm predicting its future, a great bright future. Why? Because the 1 gigabit internet will become an average. It will cost below $100 in US, and the 5G internet will also become an average for the average consumers on the phones in 2021. And at this speed, you will receive a great experience on the streaming PC game services on your devices. But in 2025, Apple iOS devices will be fast enough to avoid the streaming services. It will feature 16 cores in CPU, about 32 to 64 cores in GPU. It will produce beautiful 4K resolution content on iOS gaming devices through iOS gaming store with the similar visuals that we still have right now in 2019. I mean in 2020, and pretty much similar visual in 2019 for sure. On the little pocket devices, similar visuals in 2025. And so you don't need to stream anything. You better play locally on the iOS devices because the latency delay will be very low, and it's always better play locally, okay, due to latency delay. So it will be no need for the streaming services because the pocket devices will be fast enough to outperform today's visuals beginning of 2020 and 2019. Alright guys, so hopefully I underline it for you, but this CPU will be the best PC gaming CPU throughout the whole 2020 till in 2021. Intel will release the newer Nanotech CPUs, and those CPUs will take over again because AMD is not catching up. They did not catch up. Do not listen to those naysayers and fans. AMD did not catch up with Core i5 9600K in terms of PC gaming. And I'm not talking 1080p. You can also go ahead and put the 64 core AMD CPU and test at 800 by 600. But nobody is doing that. Right now, large screens, 4K resolution screens can be purchased for $450. Right now, you can purchase 60 Hz, 65-inch 4K resolution screen in US for $450. And just go ahead and play on that type of screen, any PC games. You will be amazed how beautiful everything is. And then just go ahead and switch on that screen to 1080p. You will see those hard edges. You will see that ugliness. You will see this 1080p, guys. Pretty much 1080p, let me tell you, 1080p gaming right now is losing 75% of the textures, pixels, almost on any 3D mesh in the games that was released in 2019, 2020. And if you're still playing them in 1080p, you're losing 75% of the pixels, details of your textures. You're loading the same topology in terms of the polygons counts, okay, but you're losing 75% of pixel count. This is what the naysayers, marketers such as Linus and Nexus Gamer not going to tell you. They're still going to test 1080p because they got paid for it in any ways. If they're going to show you 4K resolution, that's why they're screaming 4K resolution is no go. 4K resolution is future. This is what those folks were screaming to me back in 2007, that 1024 by 768 is all what you need. They were writing those naysayers, the comments, or on my YouTube channel when I opened it. And I opened my YouTube channel when I developed my video capture, screen capture software, Morose Video Capture or Ultimate Video Capture during that time. And I was capturing the gameplays faster than Fraps, with less file size than Fraps, from 2007 till 2012, when I realized in 2013 that NVIDIA Shadowplay outperforming any software capturing approaches, because it's utilizing somehow the hardware level utilization on the NVIDIA cards while it's using the Shadowplay through the software, and it's much faster hardware acceleration of the screen capture. Okay, so this is coming from the software developer, graphics designer, 3D artist. Guys, why at 1080p you're losing 75% pixels? Let me go ahead and add this information for you, because I'm pretty sure a lot of naysayers will confuse you and haters. Because right now in any games that was released in 2019, the smallest texture that they're using is 1024 pixels by 1024 pixels. And your 1920 by 1080 pixel screen, let's say you have a helmet on the player when you're playing the PUBG, right? That helmet is probably about 200 pixels by 200 pixels. That means the texture is 1024 pixels by 1024 pixels, but the whole 3D mesh rendered as 200 pixels by 200 pixels. rasterized and rendered as 200 pixels by 200 pixels. That means that you just lost 800 pixels on width and 800 pixels on height of the texture, of the details. So you must to play 4K, and even at 4K you're going to be around, that helmet will be 400 pixels by 400 pixels, but you're already going to lose about 50% of the details instead of 75. So to realize, even to load the textures, the whole game experience, the way it was envisioned in terms of even the textures, not even 4K textures, the regular HD textures, which is 1024 pixels by 1024 pixels, you will need to play the games at 8K resolution as minimum to load all the pixels out of the texture, all the details, without squeezing the pixels into one pixel and losing the details. Hopefully this makes sense, guys. So Core i5 10th generation, guys, since Core i5 9600K was ready for 16K resolution gaming, due that 6-core 6-thread CPU was utilizing below 30% at 16K resolution, or below 40% at 8K resolution gaming. 99.9 titles that I tested with 2 Titan RTXs and SLI. I would say comfortably with the Core i5 10th gen, guys, 10600K, if it will be overclockable to 5.5 gigahertz on 6-core 6 threads, will be the king for PC gaming, will be the king for PC overclockers, will be the king for PC hardware enthusiasts, because most of those folks not going to do 10 video encodings per day. They don't need to have all those cores, because all those cores, they're not fully utilized. If you, even the advanced users, to utilize all the 64 threads right now under Windows 10 Pro, even if Microsoft improved through the kernel, the core utilization, you still will need to load about 4 videos and encode them at the same time to utilize the 64 cores at least at 90%. Okay, will you do encoding at the same time as 4 videos? No, you're not. Maximum what you will do, this is what I'm telling you as a YouTuber, I do at least 2 simultaneously, and I'm playing the games at the same time. And still 6-core 6-thread CPU is good to go for this type of purposes, unless I'm using some very professional, which is not professional by the way, video encoding softwares and such and such and such. The professional softwares, guys, not utilizing the CPU for 3D rendering, and they're not utilizing the CPU for the video encoding. We're talking about the V-Ray and stuff like that, under the 3ds Max, under the Cinema 4D, under the other applications. Yes, for the standard, this professional application comes with a CPU renderer, but that CPU renderer is suck, and most of the professionals not using that renderer when they're doing the 3D rendering. Only the Nexus gamer that doesn't know what is the 3D at all, or Linus that never created his own 3D model ever in his life, will tell you that. But most of the 3D artists, they're using the extensions of the 3D renders, such as V-Ray and other kind of rays and stuff like that, that utilizing the GPU instead of CPU, and accelerating the 3D rendering by about good 2-3 times at least as a minimum. That's why they're avoiding the CPU rendering utilization through the 3D rendering, because the priority of the time is their priority in terms of the 3D rendering, because they're professionals. Same thing goes to the video encoding professional softwares that controls the motion movements and stuff like that, Arnold and stuff like that, and they're utilizing the GPU instead of CPU. But non-professional applications such as Adobe Premiere, that still doesn't have the lower end competition, they still utilizing the hardware that pretty much is very bad in terms of the video encoding. They still utilizing that hardware components, and the basic package with the 3D rendering software comes with also utilization of the CPU components, but it's not great solution, and professionals understood, and professional using the GPUs, Okay, hopefully this makes sense, guys. Thank you so much for watching. This chip at 5.3 gigahertz, which is I'm pretty sure will be able to run 6 core 12 threads at 5.3 gigahertz, such as for 10,600K. This chip will be equal to 5.5 gigahertz on a Core i5 9600K at least. And Core i5 9600K at 5.3 already outperforming any AMD Ryzen 3000 series by good as minimum 10% in PC gaming in terms of FPS. So think about it, guys, okay? Thank you so much for watching. I'm going to upgrade to only Core i5 10,600K. This CPU will be below $250 or around $250. The best price, the best CPU for anything. If you're going to encode 1 or 2 videos a day, this is your CPU. If you're going to go ahead and encode more, I advise you to go ahead and build yourself a network firm. This is how professional does. 3D rendering firm through the network or the video rendering firm. And do not build dual CPU systems because they're slow in terms of the latency delay. Build yourself dual or 3 PC systems. And 3 PC systems, Xeon's CPUs from 2017 that you can purchase, or 2016, for around $69 for CPU and motherboard for around $60, and 64 gigs of DDR3 for around $60, $69 for 64 gigs of DDR3. You can build 3 systems, Xeon system from 2017, used like new on eBay, that will outperform 64-core AMD CPU that costs $3,000, but only you're going to invest $1,200. It will outperform 64-core 128 threads AMD Ryzen CPU 3000 series. And what I'm thinking about 4000 series, 4000 Ryzen's, guys, will be mobile CPUs and APUs, and they are no match for the Intel 5 nanomicron technology. No match for the Apple. Sorry if I said Intel. For the Apple A series chips. And Apple A15 chip, guy, will underline a solid line when there is no more laptops. So we still will be on a desktop for those naysayers and PC enthusiasts and enterprise level of the servers in the data centers. It will be no more laptops. A15 chip will kill all the laptops, and it will happen in 2022. A15 chip, okay, on the iPads. It will be multitasking. They will add a lot of video edit. So they will add all the applications like you have right now on the desktop to the iPads and iPhones. One will receive an A15 chip, and A17-A18 Bionic Apple chip that will feature 16-core CPU and 64 cores on the GPU will kill the PC gaming industry and console gaming industry forever. But I'm going to, guys, record a video, one with the facts. I will prove it to you. It's coming out. Right now I'm putting some great videos for you to check. If you don't see them on the screen, go ahead and check the video description. Don't forget to smash that like button. Don't forget to respect the viewers of my YouTube channel. Positive comments. If you have some arguments, remember, arguments must be only with the facts. If you don't have a solid facts, if you have a move, or if you're trying to confuse me, look, the Honda is faster than Ferrari because the orange is the orange color. With something like this statements, it's not going to be accepted. Most likely you will get banned. Okay? And it's coming from the guy from PC Enthusiast and PC Overclocker with 21 years experience before the Linus and Nexus Gamer was in the project. They were running under the table during that time. When I built my first computer back in 1998. But I was on the computers before 1998. But when I built my first computer in 1998, keep that in mind. Alright, guys? Well, thank you so much for watching. As again, don't forget to check out my 16K resolution videos, the first on YouTube. I'm going to test almost any popular PC gaming titles, AAA titles. It's 16K resolution on my 2 Titan RTX and SLI. It's going to be the first ever 16K resolution gameplays on YouTube. Go ahead and check it out. Just visit iPlay4K.com YouTube channel or iPlay16K.com YouTube channel. iPlay4K, aka iPlay8K, aka iPlay16K, was with you today. Have a great day, and till the next time.